let's begin with the next chapter, chapter number 6, application of derivatives. Okay, earlier we have studied about the how the derivative works on the various functions, and now we are going to see how it is applicable in the real world, in real life situation, how it works. So here first we'll start with the application in the rate of change of, all right, means it maybe we talk about, you can see the picture graph here, that I have shown the pictures of slope. All right, you have find out the line of equations using the slope and all. So slope is what? The derivative of a function. Okay, slope is nothing but the derivative. Slope is what? The little change in the length y and divided by the little change in the x length. That is what the first derivative means. There is some change in y with respect to x. That's what the what I can say, the derivatives, applications of the derivative. Let's see to it. Next, now see the definitions of the rate of change of quantities. If a quantity y varies with another quantity x, means what? There is some change in the y quantity due to with respect to x, means there is some change. For example, the velocity. Velocity formula is what? A speed upon time. Okay, speed, there is a speed particular with respect to some change in a time. After some interval of the time, there is a change in the speed. That is what the velocity. Alright, so likewise here, satisfying some rule like y is equals to f of x, again f of x is some function, then dx by dy or f dash of x represents, either you write y is equals to fx or x equals to fy, it depends on the how the function is defined, represents the rate of change of y with respect to x, and it is represented as dy by dx at x equals to 0. It means what? We have taken the derivative of y with respect to x at a particular point x0. This represents the rate of change of y with respect to x at x equals to 0. Now, let us understand this concept by looking at the video. Okay, so let's see to it how it represents.
Consider the factor of steepness. On the incline, the steepness is the ratio of the change in elevation to the change in horizontal distance. This ratio, a number, is called the slope. For example, suppose the elevation of an incline increases 15 meters every 100 meters. The rider moves upward 15, horizontally 100. The slope is 0.15. A hill with a slope of 0.3 is twice as steep as one with a slope of 0.15. The bigger the slope, the steeper the hill. When the slope is large, it's no small feat to get to the top. When the slope is next to nothing, near zero, it's easy going. And when the slope is negative, it's downhill all the way at any given point. To determine the slope at a particular point, here for example, simply take another point on the hill. It doesn't matter where. Now connect the 2 points with a straight line. That line is called a chord, and its slope depends on the location of the second point. If the first and second points are reasonably close, the chord is a reasonably good approximation of the bike's path. Now, move the second point closer to the first. Move it even closer. The slope is a number, and as the points get closer together, the number gets closer to a certain value. It's reasonable to call that number the slope of the hill at that point. The line with that slope through the point is called the tangent line. And the tangent line is just what the chord turns into as the points get closer together. And the slope of the tangent line at that point is the slope of the hill. before they actually reach zero. Small numbers are marked by the Greek letter delta. Delta y is a small change in y. Delta x, a small change in x. So delta y over delta x is merely a ratio of two small numbers. When the small numbers shrink to zero, that ratio becomes a derivative, and the deltas become a new symbol, dy over dx, the symbol of the derivative, which means the derivative with respect to x of the quantity y. Once the simple mechanics are mastered, finding the derivative for just about anything is no harder than flipping a switch.
The derivative of a function is the slope of its tangent at each point. The derivative of a function is itself a function. If the function is linear, the slope is constant, and the derivative is just that constant. If y equals sine x, then dy over dx equals cosine x. If y equals cosine x, then dy over dx equals minus sine x.
Taking derivatives takes a little practice, but it's well worth the effort. That's how the sum rule works. The derivative of the sum is the sum of the derivatives. Another handy tool is the product rule.
The derivative of the product y times z is y times the derivative of z plus z times the derivative of y. Using this rule, it's possible to find the derivative of x squared. Or of x to the third power, or of any power of x.
And the value of differential calculus can be seen in the variety of its applications. For example, when a rocket moves with displacement s at time t, the derivative of the displacement is the velocity. Positive for upward motion and negative for downward motion. The derivative of the velocity is the acceleration, which is the same as taking the derivative of a derivative. That is, the second derivative of s. The acceleration is caused by the firing of the rocket,
So you have seen that how the derivative works. It's a quick revision also that we have studied in the previous chapter. All right. And now the same rule, chain rule, that if the function is defined in a some parametric form like x equals to f of t and y is again in a g of t, then we can find it out dy by dx using dy by dt upon dx by dt. All right. So this part you know how to solve it. The next is the example based on the rate of change of, find the rate of change of the area of a circle per second with respect to its radius r when r is equals to 5 centimeter. Means you know the circle, how the circle is, right? Those, so the circle here is what it says, means if I either the circle increase or decreases. Why it increase or decreases? Because of the change in the radius. All right, either the radius changes or means radius is changes, whether it is increasing or decreasing. So with respect to that, the size of the circle also changes. So that we have to find out the rate of the change in the area of the circle. So we know that the area of the circle with radius r is given by a is equals to pi r square centimeter or unit square. Therefore, the rate of change of area with respect to radius is derivative of area with respect to r. Why r? Because the area changes because of the radius. That's why. So derivative of area with respect to r is pi is constant value. So take it outside, and the derivative of r square is 2r. So, and we are asked to find out the rate of change when the r is 5 centimeters. So already you have calculated the derivative, the rate of change in the area, that is 2 pi r. Substitute the r value, you will get it 10 pi. All right, and thus the area of the circle is changing at the rate of 10 pi centimeter square. So here the rate of change of topic completes, and here starts the exercise. See, I am not discussing much more because this topic is deleted by the CBSE, but I just want to give you some idea about it. Okay, so I'm stopping over here. Thank you.